Hello dear participants, I welcome you all again here in this certificate course. In the previous few lectures, we tried to understand how can we perform one sample t-test, independent samples t-test and dependent paired samples t-test. In the one sample t-test, we tried to find out the difference between mean of one sample with the mean of universe or the population mean, that is mu. In the independent sample status, we tried to find out the difference between the mean of one independent sample with the mean of the other or the second independent sample. In the dependent paired sample status, we tried to find out the difference between the mean of sample before particular situation or the time period or the duration with the mean of the same sample after the particular situation or the time period. So all these three hypothesis tests are actually associated with the t statistic, and here we also have used the t table to compute critical value. The critical value is one of the approach to take the decision. Now we all are now shifting to a new hypothesis testing method, and that is F statistic, where we all are going to use the F table to compute the critical values, and we'll see that how can we take the decisions using the F table. And to understand this, let me welcome you all here in this lecture number 30 with the title One Way Between Groups Analysis of Variance, that is ANOVA. And this is a kind of hypothesis testing that we use here in the F statistic. So this is a part of F statistic where we are going to use the F table to compute the critical values. So the objectives of this lecture number 30 are as follows. The first objective is to make you all familiar with the procedure of hypothesis testing for one way between groups ANOVA using MS Excel and SPSS. Once we all are familiar with the procedure part and once we are having the results in our hand, then we'll try to understand that how can we read and interpret those results. So let me start this lecture with the prerequisites of the one way between groups analysis of variance, that is ANOVA. So what we need to have to perform this hypothesis? We need to have more than two groups formed by single independent variable, and we need to have one dependent variable with us. So if our data is having these two things, then we can easily perform one way between groups ANOVA. So as I mentioned here, we need to have independent variable where we need to have more than two groups. So say that the group 1, group 2 and group 3 are there. And there is one dependent variable. So this dependent variable, data for this dependent variable, it is there in group 1, group 2 and group 3. And then I'll try to find out whether is there any significant difference between these three groups or not. So one way between groups ANOVA is used to find the significant difference in the mean of single dependent variable among two or more groups formed by a single independent variable. To understand this in a better way, let me take you all to one example. So here is one example. Suppose IQ test is conducted for students of three leading schools in the city. Scores of random 10 students from each school are given below. So here are the 10 students, scores of the 10 students from the school A. Here are the scores for the 10 students from school B, and here are the scores for the students from school C. It means we are having one independent variable, that is school, and it is having three groups, that is school A, school B and school C. And we are having one dependent variable, that is marks, and from each school there are 10 students, and here are the marks, here are the scores. Fine. Now the researcher wants to test whether any significant difference exists in the average scores of the students in these three schools. So we are talking about the average scores of all the students in these three schools. It means we are talking about the population, that is mu1, mu2 and mu3, and that is the population from these different three schools. But randomly we have chosen 10 student samples, and on the basis of that we are going to test whether is there any significant difference, whether the significant difference exists in these three different schools, or whether the significant difference doesn't exist. Fine. So this is the way that if we are having such type of data, then we can perform one way between groups ANOVA. Now let me take you all ahead. How to construct null hypothesis here then? To construct the null hypothesis, we'll make a statement that there is no significant difference in the average scores earned by the students from all three schools. Or in different words, the average scores of the students from all the three schools is same. Symbolically, H0 is equal to mu1 is equal to mu2 is equal to mu3. What would be the alternative hypothesis? Alternative hypothesis would be exactly opposite to the null hypothesis. That is, there is a significant difference in the average scores. Or in other words, the average scores of the students from three schools, they are not same. They are not same. Symbolically, H1 is equal to, or H1 colon mu1 is not equal to mu2 is not equal to mu3. Now we are going to test this hypothesis. Fine. Showing graphically, say that if the population mean is same, then this distribution normal curve for all these three schools, they are same. Here is the mean. Mu is equal to mu1 is equal to mu2 is equal to mu3. But there is a possibility that the mean of two schools is equal, but there is one school whose mean is different, significantly different from the group of these two schools. Or there are also chances that all these three schools are having different means. So mu1 is not equal to mu2 is not equal to mu3. So there are different chances, but for the simplicity, when we stated the null and alternate hypothesis, here we stated this null hypothesis, and in alternate we can construct different hypothesis, but we have used this, that all the three schools are not equal. Fine. How it works, how to identify a particular school which differs from these two different schools, this part also we are going to see. This part also we are going to discuss here in this lecture. We are also going to discuss that whether the three schools are different from each other, or only a single school differs from the two other schools. How to identify that also we are going to deal here in this lecture. So let me take you all to the process of hypothesis testing. So we'll start with the process in SPSS first, and for that we need to type our data in MS Excel. So let me take you to the sample data set here in the worksheet. So here is the sample data set. Here is a independent variable school, and there are the three groups: school A, school B, and school C. And from each school we have selected 10 random samples, 10 students, and these are the scores of those different students from the different schools. Now, before going SPSS, we need to rearrange this data. We need to rearrange this data. So how to rearrange this data? As mentioned earlier, school is the independent variable for us, and there are three different groups, that is school A. So for school A we have assigned code 1, for school B we have assigned code 2, and for school C we have assigned code 3. Now here in the worksheet I'll mention the variable name here. The independent variable is school, and I have mentioned the codes, assigned codes here 1 for the school A, and these are the marks associated with the students from the school A. So here is the code 2, and here are the 10 random students, and here are the marks of those students who are associated with the school B, and here are the marks associated with the students who are actually belongs to the school C. So this is the way we need to rearrange our data, and the reason is that when we import our data in SPSS, it will identify this as a one variable, independent variable school with the different groups. Fine. And this it will consider as a separate variable, and that would be independent variable. Now let me take you all to the SPSS sheet. Now if I open my SPSS data editor, what should I do here? First we need to import our data, and to import our data simply I'll go to the file, then I'll go to open, and then I'll go to data. I'll click on data, a new pop-up window comes. I'll go to the file location, and I'll choose the appropriate file which I actually want to import here. So I'll select on this one-way ANOVA for SPSS and I'll click on open. As I click on open, a new pop-up window comes. Here again I'll have to click on OK. Now my data is been imported here in SPSS. Now the next step that I should take is I should go for variable view, and in the variable view I'll verify the things, whether the label names are there, whether the codes, necessary codes been given or not, or I'll just verify the type of the variable and the measures of variable and other arrangements that I'll do. Once I made all the arrangements, then I'll go to the data view. I'll simply click on data view. Now my data is ready for the hypothesis testing. Now how to perform hypothesis testing on this data? To perform a hypothesis testing, I need to go to analyze. I'll click on analyze. I'll go to compare means, and in the compare means, I'll go to the one-way ANOVA. If you observe carefully here, we already have seen the one sample t-test, independent sample t-test and paired sample t-test. All these three are associated with t-statistic, whereas the one-way ANOVA is actually associated with f-statistic. And that's the only difference between these two. Otherwise, in all these different types of the hypothesis testing, we are going to compare the means. We are going to compare the means. For example, in one sample t-test, we have compared the mu with one mean. In the independent sample t-test, we have compared the mean of two different independent samples and so on and so forth. Fine. Now here, if I click on one-way ANOVA, a new pop-up window comes, and in this pop-up window, all the variables are enlisted here, and here on the right side, we are having two different boxes. The first box, dependent list, and the other is factor. Now here in the dependent list, we need to put the dependent variable. So in these variables, which variable is the dependent variable that we need to identify? If we are having the plenty of variables, most of the times it happens during our research, we are having plenty of variables, we are having plenty of data. So on the basis of our hypothesis, we need to identify the appropriate dependent variable, and we'll have to put this dependent variable here, and very carefully we'll have to identify the factor variable, that is independent variable with its group, and we'll have to put that factor variable here in this box. So here in our case we are having only two variables. So it is very easy here to identify the dependent variable. I'll just click on the marks because marks are the dependent variable. I'll click on this arrow. My marks are there in the dependent list. Now simply I'll click on the school because school is a factor variable, and I'll put that variable here in the factor. Now I'll simply click on OK. As I press on OK, I'll get my result. So here is my ANOVA result, analysis of variance. Fine. Now to take the decision, we are having two approaches. The first approach is the p-value approach. So where is the p-value? Where to get the p-value? Here is the p-value. Wherever the SIG, this wording is there, then this value associated with this SIG is actually p-value. P-value is 0.0001. So here it is p-value. And what is the decision rule? Decision rules are here. My p-value, if it is less than 0.05, that is alpha, then we reject the null hypothesis. So what is our null hypothesis? That is mu1 is equal to mu2 is equal to mu3. This is our null hypothesis. We reject this, and what we accept? We accept the null hypothesis, that is mu1 is not equal to mu2 is not equal to mu3. So this we are going to accept. It means that there is a significant difference in the average score of school A, school B and school C. So this is the way that we interpret using the p-value approach. Now let me take you all to the critical value approach. To understand the critical value approach, we need to first identify the F statistic value. So here is the F statistic value, that is 8.471. Now how to take decision using critical value approach? For that, we need to have the critical value. And on the basis of critical value, we take the decision. For example, if my F stat is greater than whatever is the critical value, then we reject null and we accept alternate hypothesis. So the rules for the critical value are different than the rules for p-value approach. Fine. So we are having the F statistic, that is 8.471, but we don't have critical value here. To find out the critical value, we need to consider these two degrees of freedom, that is 27 and 22. Now what is this 27 and this is this 22 degrees of freedom? If you remember, somewhere in the previous lectures we have used n minus 1 degrees of freedom. N is the number of observation, and as we all know, we are having the three schools: school A, school B and school C. So between the groups, how many groups are there? Between the groups there are three groups. So n minus 1 would be 3 minus 1 and it would be 2. So this 2 is the degree of freedom for the between the groups. Between the groups. Fine. And in each group we are having how many random samples? So random samples n is equal to 10 here. Here it is also 10 and here it is also 10. So all together total n is equal to 30. But if I consider n minus 1 here, n minus 1 here and n minus 1 here, then it becomes 9 is equal to 27. So here is the within the groups. Within the groups. Fine. Within the groups, degrees of freedom are 27. Now on the basis of this 27 and 27 and 2, I determine critical value. Now how to determine critical value? To determine critical value on the basis of degrees of freedom, we need to go to F table. And where is the F table? F table is available in every statistics book. Here is the copy of F table. Now where is 27? Here is the 27 row within the group and here is the 2. Fine. 2 is the degrees of freedom for the between the groups. Now if I go to that respective column and to that respective row, the cell where the column intersect the row, that value represents the critical value and it is 3.35. Now if I go further and if I compare this F statistic, that is 8.471, so this is F stat, fine. If I compare this with the critical value, that is 3.354, then this is greater than this critical value. That is why here is the rule for the decision. If F stat is greater than critical value, then we reject the null. And what is the null hypothesis? Mu1 is equal to mu2 is equal to mu3. So this is a null hypothesis. We reject this and we accept what? We accept the alternate hypothesis that mu1 is not equal to mu2 is not equal to mu3. So we accept this thing. Our critical value is here and our F statistic value, it is greater than this critical value. That is why we reject the null hypothesis. We reject the null hypothesis. A more important thing is, whenever we are working with the F statistic in one way ANOVA, we work with the one tail test. So in F statistic, we always works with the one tail test. There is no the other tail. Fine. On the one side only we take the decision. So this is the thing that we should always remember. Now if I go further, now here we already have seen that on the basis of p value, that's fine, it is less than 0.05. So we have accepted that these three groups, they are not same. There is significant difference between these three, but there are chances that there are somewhat two groups which are equal and only one group which differs from these two. So such chances are there. Or from this alternate hypothesis, if we just want to identify which specific group actually differs from the other group, if we want to identify that, again we need to go to the previous steps which we followed to get the result for one way ANOVA, and we need to click a particular option using which we can easily identify that which group differs from which group. And to understand that, let me take you again to the data view. Now here I'll go to analyze, I'll go to compare means, and I'll go to one way ANOVA again. Now here I'll just select these variables and I'll put those variables in their appropriate places. Now before going to OK, if I click here on the post hoc option. So here is one post hoc option, and this post hoc option help us to identify the particular group which differs from the different other groups. Fine. So I'll just simply click on the post hoc this option, and as I click on post hoc, I'm having plenty of methods here. We are having plenty of methods available here, which methods will help us to identify the group which differs from the other groups. Now here we are going to use this two key method. Using two key method will identify which group differs from the other group. So I simply click here on the two key and I'll click on continue, and then I'll click on OK. Here are the results. Now the first table is the ANOVA result. This table already we have discussed. Fine. So we'll go to the second table, and there is one more table. So let me scroll this screen. So I'll just go little down. Here are the two tables. Now let me discuss on these two tables. So which value we are going to compare, which value we are going to consider here is this significant value, and this significant value is nothing but the p value. And as we all know that if our if p value is less than 0.05, we reject null and accept alternate hypothesis. That this is the thumb rule that we all know. Fine. Now let me take you to the first value, 0.118. What does that mean? So here is a 0.118. So this value is actually associated with two schools, school A and school B. What does that mean? It means school A, the mean of school A and mean of school B, they are equal. That is null hypothesis. Fine. Now here is the p value, and what is alpha? 0.05. Now here the p value is greater than 0.05. So we do not reject the null. We do not reject. When on the basis of this value, if I take the decision to not to reject the null, it means the average score of school A and average score of school B, there is no significant difference. It means this is whole true. There is no significant difference between these two schools. Now let me take the other value. Here again 0.118, and this value is associated with school C and school A. School A and school C. Again, if I mention the null hypothesis that school A and school C, there is no significant difference, and this is my null hypothesis. And if we compute the p value, and p value is 0.118, this is again greater than 0.05. So again we do not reject the null. It means there is no significant difference between the score of school A and score of school C. Now we need to find the value which is less than 0.05, and that value is here 0.001. So this 0.001, this value is actually associated with school C and school B. It means, suppose in this case, if I mention the null hypothesis that school B and school C, there is no significant difference between school B and C, and my computed value here, p value is 0.001, it is less than 0.05. So what would be the decision? We reject null and accept alternate hypothesis. It means that this B and C, they are not equal. So here say that mu2 is not equal to mu3, but mu1 and mu1 and mu2, they are equal. Mu2 and mu3 are not equal. Take one more example here, 0.001. Again here, school C and school B. In the inverse case, here school C was here was the school B. Now here in the last row, school B is here and school C is actually interchangeably, they are placed here. So again we are getting the same value here, C and B Null hypothesis C is equal to B, but again 0.001 it is less than 0.05, so we reject null, accept alternate, that is C and B are not equal. So this is the way we take the decision. Here using 2 key we get the significant p values, and on the basis of p values we can easily identify which two groups are significantly different. If they are less than 0.05, it means they are significantly different from each other, and if they are greater than 0.05, it means there is no significant difference between those respective groups. So this is the way that one way that we can identify which two groups are equal and which one group differs from the other group. Now there is the other method. Come to the third table here, homogeneous subset. So here you will find that there is subset 1, subset 2. It only gives us the value for the particular groups who are homogeneous in nature. What does that mean? Let me explain here. So here the schools are arranged in ascending order considering their mean. So these are the mean values, mean scores. So the lowest mean score comes here, the higher comes here, and the highest score comes here. But here are the two groups. So these two values are associated with school B and school A. It means there is no significant difference between the values of these two schools, A and B. They are equal. That's fine. Come to the second group. Here the two values are in the one subset, and that is school A and C. So A and C there is no significant difference. But if we compare this value 12.50 and 8.50, so there is no third group, or these values are not in this one subset. It means B, school B and school C, there is a significant difference. It means B is not equal to C because this group is not here. That group in a single subset, it is not present here. So this is the other way that we can identify that which group differs from which group. Fine. I hope you all understood this. So in initial phase, we actually tested the hypothesis, and then we also seen that how can we check, how can we see that whether the this here in our case we find that there are two schools having the same, no significant difference in the mean, but there is one school who is having the different view. Fine. So this is the way that we compare the things. This is the way we read and interpret the data. Now let me take you to the MS Excel. One way ANOVA using MS Excel. For that, again, this is the data that we have used for SPSS, but for MS Excel, again, we need to rearrange the data. So what we'll do? We'll again go back to our base data, base typed data. Now using this data, we are going to perform one way ANOVA. For that, I'll go to data, I'll click on data, then I'll go to data analysis, and here I'll find the ANOVA single factor. Single factor. What does that mean? Single factor means, if you remember, we are having one dependent variable and we are having only one independent variable, that is school. But in the school we are having three categories, three groups, A, B and C. So single independent variable, that is independent variable, is a factor, single factor with different groups. Fine. So I'll choose that ANOVA single factor. I'll click on OK. Then a new pop-up window comes. Here I'll just select on this and I'll just drag, I'll just select my whole data. Now here be careful. Here I have selected these variable names too. Fine. Now if I go further, I'll click on this, and then most importantly, if you select your data with the variable names, then you will have to click this box, label in the first row. If you select your data from these numbers below, then there is no need to click here on this thing. Fine. Then simply I'll go to the output range and I'll select the output range where I actually want my result, and then I'll press on OK. Here is my result, and in this result, again, here is my p-value 0.001. It is less than 0.05. So we reject null, accept alternate hypothesis. Here is my F statistic, that is 8.47 F stat. And in MS Excel we get the critical values too. Here we need not to go to the F table because we get the critical value also. So here is the critical value, that is 3.35. This is greater than this. So also we reject the null and accept the alternate hypothesis. Fine. So this is just kind of a summary table. School A, school B, school 3, count, random, number of observations, sum, and here are the average values. Here is the variance. If we square root, then we get the standard deviation. All that part is there. Now let me compare the output from the MS Excel and output SPSS output. Here F statistic 8.471, here F statistic is 8.471. P value 0.001, P value 0.001. Fine, we get the same result. If you are comfortable with MS Excel, you go with MS Excel. If you are comfortable with SPSS, you go with SPSS. We all are going to get the same result. We all are going to get the same result, but with somewhat different design. So that is all about the MS Excel output and SPSS output. So what about the interpretation? Again, what was our null hypothesis? Null hypothesis was there is no significant difference in the average scores earned by the students from all three schools. So what is our test result? Test result is on the basis of p value 0.001 is less than 0.05. So we reject null and accept alternate hypothesis. Now what is our alternate hypothesis? Alternate hypothesis is there is a significant difference in the average score earned by the students of three schools. So this is the way that we read and interpret the result for one-way ANOVA between groups. I hope you all enjoyed this lecture and understood this lecture, and I hope you all will use this method in your research. So far this lecture is concerned, we'll stop here. In the next lecture, we'll discuss on the two-way between groups ANOVA. Till then, thank you.